So, let's start. Number 10. The lunar dust that acts alive. When astronauts from the Apollo missions first set foot on the moon, they were ready for silence, rocks, and dust. What they didn't expect was dust that behaved like it had a personality. Lunar dust wasn't just regular dirt. It was clingy, reactive, and a little bit evil. The moment the astronauts stepped onto the surface, the fine gray powder stuck to everything. Boots, gloves, helmets, even the inside of the lunar module. They tried brushing it off, but it refused to move. It embedded itself into the fabric, scratched visors, and irritated lungs when inhaled. Neil Armstrong said it smelled like burnt gunpowder, which is odd because there's no oxygen on the moon. Nothing burns there. So why would it smell like that? When scientists got the samples back to Earth, things got even weirder. The moment lunar dust touched our air and humidity, it started to change. It reacted with oxygen and water vapor in ways that didn't match any normal chemical process. Some particles fizzed, sparked, or fused together as if they had been waiting for something to trigger them. NASA scientists realized the dust had been electrically charged by solar radiation for billions of years. Each grain acted like a tiny static battery, but even after neutralizing it, they couldn't fully explain its properties. The dust contained nanometer-sized glass shards, sharp enough to slice through seals and filters. It also stuck together in strange clumps, as if magnetized. Some scientists joked that it behaved almost alive, crawling over surfaces and reattaching itself as if it wanted to go home. The real explanation probably lies in its atomic structure. Constant bombardment by micrometeorites and solar winds gave the dust a kind of electrochemical memory, which made it behave differently from any soil on Earth. But still, the way it clings, reacts, and changes makes it feel less like dirt and more like some alien material trying to adapt to our physics. Number 9. The helium-3 that doesn't belong here. Among the most valuable things Apollo astronauts brought back from the moon wasn't a rock or a mineral. It was something invisible. Helium-3. This isotope of helium barely exists on Earth, but on the moon, it's surprisingly common. Helium-3 is a stable isotope, meaning it doesn't decay like radioactive elements. And here's why it's fascinating. It could be the perfect fuel for future nuclear fusion reactors. Clean energy, no radioactive waste. But what puzzled NASA scientists wasn't that helium-3 was there. It was how it was distributed and what its isotopic structure revealed. On Earth, helium-3 appears mostly from decayed tritium, a man-made source. On the moon, however, it's formed by the solar wind embedding particles into the lunar surface. That should create random concentrations depending on exposure. But that's not what they found. The helium-3 spread across the surface in a weirdly uniform layer, too smooth, too even, like it had been evenly processed. Even stranger, when scientists measured the isotope ratios, they didn't match expected solar models. The helium-3 atoms had energy signatures that implied they'd been altered by a process unknown to Earth physics, possibly by solar events that we've never recorded, or by interactions with unknown cosmic particles. In short, it's like the moon had been cooking helium-3 under conditions that simply don't happen anywhere else we've seen. One NASA scientist said, "It's as if the moon's surface is a solar reactor running on alien settings." The discovery sparked wild theories. Some claimed the uniformity hinted that the moon might have once had a thin atmosphere that spread particles evenly. Others, less scientific but more fun, wondered if the helium-3 was the leftover residue of an ancient technological process. Whatever the truth, helium-3 remains one of the few substances that genuinely doesn't fit our physics perfectly. On the moon, it forms effortlessly. On Earth, it's almost impossible to make. Sometimes the difference between here and there is more than distance. It's the laws of nature themselves. Number 8. The Martian meteorites that age backward. When NASA scientists started collecting meteorites that came from Mars, they thought they were just studying ancient rocks. Instead, they found objects that seemed to be breaking one of the most fundamental rules of physics: radioactive decay. These meteorite pieces of Mars, blasted off by massive impacts millions of years ago, were dated using isotopic decay methods. but something didn't add up. The chemical composition suggested they were billions of years old, yet some isotopes appeared to have reset their atomic clocks. In other words, parts of the rock were older and parts seemed brand new. That's not supposed to happen. Radioactive decay is consistent everywhere. On Earth, it follows strict half-lives unaffected by external conditions, but these Martian samples seem to have been exposed to forces strong enough to scramble their atomic structure. Some scientists believe extreme bursts of cosmic radiation far beyond what Earth experiences might have temporarily rearranged their isotopes. Others suspect Mars's magnetic field, which flips and fades irregularly, might have once created massive energy surges that altered atomic behavior. A few even proposed that Mars could have experienced geological or electrical events that operate on a scale we simply don't understand. To make it even stranger, some of these meteorites contain tiny crystal formations that seem partially melted, but not in a way any known process could produce. It's as if they were heated and cooled simultaneously. Like, time itself stuttered for a moment. In the end, the Martian meteorites tell a story that doesn't quite fit our textbooks. They act like time is flexible there, like decay and age aren't the same thing. It's not proof of alien tampering or anything supernatural, but it does suggest that physics, at least as we understand it, might not always play by its own rules. Number 7. The asteroid metal that shouldn't exist. In the 1960s, NASA's early missions started collecting samples from asteroids that had crashed onto Earth long before humans even existed. Most of these meteorites were just lumps of rock and iron, nothing special. But one particular fragment, later linked to asteroid 16 Psyche, changed everything. When researchers examined its composition, they found something bizarre. The metal didn't behave like any alloy found on Earth or made in any lab. It contained perfect ratios of nickel and iron that should have required deliberate smelting, yet it was naturally formed. Even stranger, the crystalline structure was almost flawless, showing patterns more consistent with engineered metal than geological formation. How could an asteroid forge something so perfect? When they tested its magnetic properties, they got another surprise. The sample reacted to magnetic fields in inconsistent ways. It would repel a magnet one moment, then attract it the next, as if it had memory or awareness of field changes. Some scientists thought the metal might be a remnant of a planetary core, maybe from a shattered protoplanet, but even that didn't explain the symmetry of the atoms. And here's where it gets weirder. When the fragment was bombarded with radiation to test its stability, it generated small, measurable electrical currents like a microscopic power cell. Some researchers compared it to a naturally occurring circuit, something that shouldn't even be possible outside deliberate design. NASA eventually classified the alloy as non-terrestrial structured metal, which is basically scientific code for we have no idea what this thing is. To this day, 16 Psyche remains one of the most mysterious bodies in our solar system, a metallic world that seems too uniform, too pure, and too ordered to be random. If the universe really did form this thing naturally, then it's proof that physics can do engineering better than we can. But if not, then we might be looking at something that's not just ancient, but manufactured. Number 6, the cosmic dust that breaks thermodynamics. When NASA's Stardust mission returned to Earth in 2006, it carried one of the strangest payloads ever collected, actual particles from interstellar space. These were microscopic grains of dust that had been drifting between stars for billions of years. The idea was simple. Analyze them, understand how stars form, and maybe learn about the origins of life. When scientists looked at the samples under electron microscopes, they found things that shouldn't exist. Some particles were made of materials that could only form at both extremely high and extremely low temperatures at the same time. It was like finding ice that had been baked in an oven. The crystalline structures inside the grains were stable beyond what thermodynamics allows. They contained isotopic ratios that matched no known stars or stellar processes. Some elements were arranged in perfectly repeating patterns, while others seemed completely random, like chaos frozen into order. The real kicker came when they tried to heat one of the particles in the lab. Instead of melting, it released bursts of infrared light, almost like it was resisting temperature change. Scientists had to rewrite parts of their models for how matter behaves in deep space because these grains acted as though they were formed in a place where normal energy exchange simply doesn't happen. NASA described them as thermodynamically anomalous. That's a polite way of saying physics says no, but the dust says yes. Some astronomers think the particles might have come from the debris of a dead star, material crushed under gravity so intense that it rewrote the atomic rules. Others think they might be fragments of matter that formed outside our galaxy altogether, in regions where time and energy behave differently. Whatever they are, they prove one thing. Not everything that floats through space follows the same rulebook we do. Some of it might be running on an entirely different version of physics that we haven't unlocked yet. Number 5. The strange energy coming from Voyager's edge. When NASA launched Voyager 1 in 1977, the plan was simple. Explore the outer planets, then drift quietly into interstellar space. What scientists didn't expect was that decades later, Voyager would still be sending signals, and that those signals would get weird. As the spacecraft crossed the boundary of our solar system, the heliopause, its instruments started detecting a low-frequency hum. It wasn't cosmic radiation, it wasn't solar wind, and it wasn't interference. It was a background vibration like the static of the universe itself. But here's the odd part. The frequency didn't match any known natural source. Even stranger, when the probe moved farther away, the energy signature shifted as if it were interacting with something that wasn't supposed to be there. Some physicists called it plasma oscillation from interstellar space. Others quietly admitted it could be something beyond our current physics, an unknown field or layer between our solar system and the true vacuum of space. Voyager's instruments also began returning strange magnetic readings, tiny fluctuations that didn't line up with any expected cosmic model. At one point, the spacecraft's magnetic sensors picked up what looked like a directional push, as though something invisible was subtly steering or dragging it. NASA has stayed cautious, calling the phenomena unexplained plasma interactions. But several researchers have noted that the data looks a lot like the craft is passing through regions of space that don't obey the same electromagnetic laws as ours. In short, Voyager might be brushing against the edges of physics itself, regions where space bends differently, where energy doesn't decay the way it should. It's possible we're witnessing the first direct signs that our universe isn't uniform, that out there, just beyond our solar bubble, reality might start to glitch. So, when you think of Voyager quietly drifting in the dark, remember, it's not just exploring space, it's exploring the limits of what we even call real. Number 4. The space bacteria that shouldn't be alive. In 2010, something strange showed up on the exterior of the International Space Station. Tiny bacterial colonies were found clinging to the surface of the station's solar panels, exposed to hard radiation, freezing vacuum, and zero protection. That alone was bizarre, but the real shock came when NASA and Russian scientists analyzed them. The microbes weren't Earth-like. Their genetic markers didn't match any known terrestrial bacteria. They also seem to survive conditions that should destroy DNA instantly. Imagine something living on the skin of space itself. No oxygen, no water, and constant ultraviolet death rays. Yet, there they were. When researchers brought them back to Earth for study, the bacteria refused to behave. They replicated slowly, but their cellular structures didn't break down under radiation. Even more oddly, their metabolic reactions didn't line up with any normal biological pathways. It was as if they'd evolved under different chemical rules. One theory is that these bacteria were actually from Earth, microscopic hitchhikers that had mutated under cosmic radiation into something entirely new. Another more unsettling theory is that they came from space dust or micrometeorites that collided with the station. In other words, alien in origin. But the weirdest part? They seem to thrive better in microgravity. When grown under normal Earth gravity, they became unstable, their cell membranes collapsing like they were suffocating under pressure. That means two things. Either they adapted to space faster than anything we've ever seen, or they didn't come from here to begin with. NASA has stayed cautious, avoiding words like alien life. But these organisms have been repeatedly confirmed by independent labs. They don't fit our biology or physics. They challenge one of science's favorite assumptions that life can't just appear or survive out there. Yet these microscopic stowaways seem perfectly fine ignoring that rule. It's ironic that after decades of searching for alien life in distant galaxies, we might have found it clinging to our own front porch. Number 3. The Titan methane lakes that break chemistry. When NASA's Cassini spacecraft flew past Saturn's moon Titan, it found something that shouldn't exist. Entire seas made of liquid methane and ethane hydrocarbons that, on Earth, are gases, but Titan's freezing temperatures turned them into shimmering black lakes stretching for hundreds of kilometers. That was weird enough. But Cassini's instruments detected something even stranger. The methane levels on Titan's surface didn't make sense. They should have evaporated into the atmosphere millions of years ago, but they're still there, constantly replenished. Something is keeping Titan's chemistry going in ways our models can't explain. Scientists first thought there might be volcanoes spewing methane from underground, but Cassini didn't find any. Then they looked at the atmosphere and realized something else. Hydrogen was mysteriously disappearing near the surface, as if something was consuming it. Now, here's where things get interesting. On Earth, certain microbes use hydrogen and methane to generate energy. So, what if Titan has its own form of biology, one that breathes hydrogen and eats methane instead of oxygen? That idea sounds crazy, but the numbers match. The surface chemistry shows balance, not chaos. Something is maintaining Titan's methane cycle like a living planet, and the methane itself behaves oddly. It absorbs and reflects sunlight in unpredictable ways, like it's being altered by ongoing reactions no one understands. Cassini's last dive into Titan's atmosphere before it was destroyed sent back final readings that made no sense. Density changes, unexpected electromagnetic pulses, and chemical ratios that suggested movement. Some scientists think Titan's entire surface acts like a slow-breathing organism, chemical engine running on alien thermodynamics. So yeah, Titan might not just be a frozen world, it might be an entire alien ecosystem, one that doesn't care about our version of chemistry. Number 2. The particles that act like they're from another universe. In 2020, NASA's Antarctic Impulsive Transient Antenna, ANITA project, a balloon experiment floating high above Antarctica, detected something that broke every rule in the physics textbook. Instead of detecting cosmic rays coming down from space, ANITA found high-energy particles shooting up from the Earth. That's impossible. Cosmic rays can't pass through the planet, they get absorbed. Yet, ANITA picked up signals of tau neutrinos coming from below, traveling as if Earth didn't even exist. NASA scientists double-checked everything. The data, the instruments, the atmospheric noise, the results stayed the same. Particles had apparently emerged from the planet, moving backward through space-time. Or at least that's one way to explain it. One interpretation is that these particles came from a parallel universe where the laws of physics are reversed, time runs backward, and matter behaves differently. Another idea is that we're witnessing the first signs of unknown particles that interact with gravity and space in ways we don't understand yet. Even more strange, other experiments have since confirmed similar anomalies. High-energy cosmic particles that seem immune to decay are moving through solid rock, bending around magnetic fields, and ignoring thermodynamic limits. NASA's official stance? Unexplained high-energy neutrino events, which is the polite government way of saying physics broke, and we don't know how to fix it. If those particles really are from another universe, then technically NASA's already caught a visitor from one. Number 1. The object that spins forever, almost. When NASA launched Pioneer 10 in 1972, it became the first spacecraft to travel beyond the asteroid belt, a metal time capsule now drifting through deep space. It was supposed to be predictable. We knew its speed, its fuel use, its trajectory. Physics had this all figured out, or so we thought. Decades later, scientists noticed something they couldn't explain. The probe wasn't where it should have been. It was slowing down, not a lot, but enough to defy Newton's perfect math. The slowdown didn't match any known force, not solar radiation, not cosmic dust, not gravity, and that wasn't the only mystery. Pioneer 10's spin, which keeps it stable and oriented, refused to fade as expected. It just kept turning, endlessly, like a toy top that forgot how to lose momentum. NASA engineers dug deep. They built models, ran simulations, and even calculated how much heat was bouncing off the spacecraft's antennas. Maybe tiny photon packets of light were giving it a microscopic push, but the numbers still didn't fit perfectly. Some data suggested a small, constant force was tugging on the probe from behind, like space itself was whispering, "Not so fast." The same thing showed up in Pioneer 11, Ulysses, and even New Horizons. Each spacecraft behaved slightly off from what physics predicted. It's like something out there was rewriting the smallest rules of motion. Rules we thought were carved in stone since Isaac Newton first dropped an apple. Today, Pioneer 10 is over 12 billion kilometers from Earth, heading toward the Taurus constellation. Its transmitter went silent years ago, but its strange journey still haunts scientists. It's a cosmic ghost, drifting endlessly, proof that even in the vacuum of space, something unseen can bend the math. And maybe that's the point. The universe doesn't owe us explanations. Sometimes it just leaves a small spinning object out there, reminding us that we still don't fully understand the playground we're floating in. Thank you for watching and sticking till the end. We've got plenty more videos coming in the future. Hit that subscribe button so you don't miss them. See you in the next one.